Okay, welcome back, grade 11s. We are going to now go into chapter 7 a little further and look at different types of sequences. So I'm going to talk about two types of sequences. One video will be on arithmetic sequences, and the next one will be on geometric. So you're going to learn what these things are, how to generate a general formula for each that can then help you predict other numbers in the sequence. And you're going to find your practice on page 424. I'm asking you to do questions 1, 3, 4, 5, and 6. Number 8 is good, but you can skip over the recursive section. So I'm going to teach you what that means in a second. And then 9 through 15 are also good ones to look at. All right, so first of all, let's just talk about sequences in general. So you can see here we have 3 figures of these cubes that were placed in this type of arrangement. So using cubes to make the following shape, McCunn wants to know if the number of cubes in each figure represent anything special. And if he can figure out a pattern to these diagrams without actually having to draw the next ones in the sequence, he can now then determine, using that pattern, how many cubes will be in the 100th picture. All right, so this is picture number 1, picture number 2, picture number 3. We can think of this as placement number 1, placement number 2, placement number 3. Okay, so if you want to think of them as positions. In position 1, and we'll use the letter N to denote position number. In position 1, we have 1 block. In position 2, we have 1, 2, 3 blocks. And in position 3, 1, 2, 3, 4, 5 blocks. So right now, our sequence looks like 1, then a comma, then a 3, then a comma, then a 5, then a comma, and it keeps going. We just don't have the other pictures. But if we can figure out the pattern here, we can figure out what's happening in the 100th position. So n equals 1, n equals 2, so position 1, position 2, position 3, dot, dot, dot. We are trying to get to position 100. We want to figure out what's in the 100th spot. Now, obviously, you see a pattern, right? You think, how do I go from 1 to 3, and is that the same thing that's happening between 3 and 5? And it looks like we're adding 2 to get to the next one. So that means the next position should be 7, and the next one should be 9, and then the next one should be 11, right? That seems to be what's happening here. If we can figure out a pattern based on the previous value, which is what we did, so the previous value add 2, the previous value add 2, the previous value add 2, we can come up with what's called a recursive formula. So it's based on what's happening to the previous term, how we add to it, multiply to it, subtract from it to get the next term in the sequence. So what this means is that any value, so any value, which we denote as a t with a subscript n, n for any position, t for any term, so any term in any position, can be found if we take the guy in front. So if this is position 3, this is position 2. Well, position 2 is position 3 subtract 1. So if we want to find who's in position 3, we have to look at who's in position 2. Well, if position 3 is n, position 2 would be n minus 1, right? The guy in the spot before n. So if we look at the number, the value, sitting in the spot before the one we're interested in, and we add 2 to it, what we get is this formula that will always help us then figure out who's in the next spot. So this is called a recursive formula. The good thing is it's pretty simple and straightforward. The bad thing is you have to always know what number came before the number you're interested in. So if you're interested in position 100, like we are, then that means you need to know position 99, right? And in order to plug it in, who's sitting in the 99th spot? And then you add 2 to him. Well, in order to get the 99th spot, you need to know the 98th spot. To know the 98th spot, you need to know the 97th spot. So you basically have to fill in the entire sequence. That's not very useful, obviously, in this case. So there must be another way of generating a formula that is not based on the previous numbers in line. So what we're going to show is, well, how else can we figure out what this formula might look like? So let's look at this little grid here, this little axis system. If we put the value of n, so first position, second position, third position, fourth position, fifth position, down at the bottom. And then here we're going to put value, so the number of cubes in this case. We're going to graph the number of cubes sitting in each spot. 1, 3, 5, 7, 9. So the first position had 1 cube, the second position had 3 cubes, third position had 5, 7, 9. You obviously get this graph. So it looks like the rise and the run. We rise 2, we run 1. So it looks like the slope is 2 over 1. And it's definitely linear. So it's showing linear growth with a rise-run sequence of 2 over 1. So our first differences would be 2 in that case. So it's, what type of relation is this? It is definitely a linear relationship. What do the first differences represent? The slope, right? Delta y is 2, delta x is 1. So delta y over delta x, if you remember, is your slope. And we get a value of 2 over 1. So we know that to get the 100th term, we just said that we're going to have to figure out who's in the 99th spot and add 2 to him. Well, I don't know who's in the 99th spot, so this is very inconvenient, right? This recursive method is very inconvenient. I'm not going to fill in 99 spots in the sequence. I'm just not going to do it. So let's figure out another way, right, without having to use previous numbers, just based on what we know, 1, 3, 5, 7, right? That's all we need to know. We should be able to figure out who's in the 100th spot. And the way we do that is by using what's called the general term. So we're going to go through some terminology right now. So those of you that printed out the note, you have this kind of definitions list in front of you. So we're going to go through these definitions, and then we're going to go back and use the formula to answer that question. So first of all, you need to know what a sequence is. So a sequence is just a list of numbers separated by a comma. I'll add that in. So they're separated by commas. And there's some kind of pattern usually to them. So ours was 1, 3, 5, 7, and then we go dot, dot, dot when it keeps going and we don't know when it finishes. This dot, 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 three dots is called an ellipsis. And it just means that it keeps going and there's nothing here at the end. So that means I don't know when it finishes. I don't know what number's in the last spot. If I saw a number here, after the dot, 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 that number would indicate it's the last number in the sequence. So the sequence stops at some point. So that's what a sequence is. The word term is a particular value. So it's a number in the sequence. So it's a value sitting in a particular spot. So the term 3 has the value 5. Term 4 has the value 7. So T3, term 3, who's sitting in the third spot? That is equal to 5. Who is sitting in the first spot? So the term in the first position is 1. Okay, that's the way you would read that. So it's what value is sitting in that spot. What value is sitting in that spot in the sequence? Now, arithmetic, as you just saw, is a sequence that has the same difference. So this common difference between consecutive terms. So you're getting from one term to the next term. So again, 1, 3, 5, 7. Add 2, add 2, add 2. Right? We could be subtracting 2, subtracting 2, subtracting 2. It doesn't matter if you're adding or subtracting to get to the next term. The fact is you're always doing the same thing, whether it's adding or subtracting, to go from one term to the next. And that means there's a common difference. Difference means subtraction. And you get this common difference, which we denote with the letter D, by going term 2, take away term 1. Term 3, take away term 2. Term 4, take away term 3. It doesn't matter which pairings you put together. It's like doing your delta y's, your first differences, right? Number below minus the number above. Number below minus the number above. That will always give you your common difference, and arithmetic sequences are those that have a common difference. Now, I'm not going to go through how it was basically found, but what we're trying to figure out, is there a general formula that will help us determine any number in any sequence? And the answer is yes. So any general term, which is your general formula, so term just means formula. The general formula, which is denoted by Tn, so it works for any position. It allows you to find any value in any sequence. That's why it's really good. So let's show how it actually came about. So the number in the front, every sequence, so 1, 3, 5, 7. I'll just keep going back to the same one. This guy, he's in the A spot, right? Just like the alphabet, right? First guy, first spot, A. What we had to do to get to the next spot is we had to add 2. That 2 is our difference, right? That common difference is 2. So the number 3 is really the first number plus that common difference. The number 5 is the first number plus 2 again. So plus D plus D. So plus a D plus a D, better known as A plus 2 Ds, sitting in to get to the third spot. The first number plus 2 differences. This would be the first number plus 3 differences. Okay, so that's what this is showing you here. First number, then the first, to get to the second spot, it's the first number plus a difference. To get to the third spot, it's the first number plus 2 differences. Now you'll notice that the number of differences, so this is position 2, there's only 1 D here. Position 3 has 2 Ds added in. Position 4 has 3 Ds added in. So the number of Ds that you have to add, the number of differences that you have to add, is always 1 less than the position spot, the position number. And that's why it's n minus 1. So to get to the fourth spot, we're going to have to add in 3 Ds. 4 minus 1 is 3. So n minus 1 is the position value, subtract 1, number of Ds added on to the first term. This is your general arithmetic sequence formula. Tn equals A plus n minus 1D. Okay, so we talked about recursive. Recursive is a sequence where one term is based on the next term. The next term is based on the term in front of it by doing something to it, like adding 7 or subtracting 2 or whatever it is. And we can get a formula that way, but it's not very useful because you always have to know the previous numbers. This, you don't have to know anything except who started the sequence and what position number you're interested in, and what is the common difference to get you to the next term in line. Okay, so let's go back now to that first question of the blocks and try and figure out how many blocks would be in figure 100 then, by using our sequence. So on the side, we know that our formula is Tn equals A plus n minus 1D. Okay, so if that's our formula, the A value is the number in the beginning of the sequence. Well, the number in the start was a 1. So we obviously have to put an A value of 1. The common difference, because we also need that in the formula, would be T2 minus T1, 3 minus 1, 5 minus 3, 7 minus 5. It doesn't matter what pairing you take. You're going to get the same answer of 2. Common difference of 2. The n that we're interested in the 100th position. So the 100th diagram. So n would be 100. So what we're going to do is we're going to place these numbers into the formula. T is still T, so it's the value in the 100th spot. N now gets replaced with 100. A takes on the value 1 plus bracket n takes on the number 100. Then we subtract 1 and we times that all by d, which is 2 in this case. We do order of operations. So 1 plus 99 times 2. 99 times 2, we obviously have to do that first. 1 plus 198, which in total gives you 199. So there should be 199 cubes in the 100th diagram, the 100th figure of that sequence. There should be 199 cubes in that spot. So you notice that it took 99 D's added on to the first number to get us there. And we didn't have to know who was in the 99th spot, the 98th spot, the 97th spot. So that's why recursive isn't all that useful, because you always have to know then other numbers in the sequence. Here we just need to know the first number, the common difference, and what position we're interested in. And we can go straight to that position. So it's like you're going to a particular value, an XY point on the graph. So basically I extrapolated this line and I went all the way to where 100 would be. And I looked up and I said, oh, it's going to have 199 cubes. That's basically what I did. So it's a quicker way of doing that. So now that we've done that and we've done some basic definitions, very useful definitions, next we're going to now apply this formula to different situations. So if you didn't print it out, that's fine. These are easy examples to just copy out for yourself. Let's go back up to the top there. There we go. So let's go back to practicing with that basic formula. So determine the general term, which means formula. Find the formula for this sequence. So it's just some random grouping of numbers, 3, 12, 21, 30. So first of all, is this arithmetic? Well, what do I do from a 3 to get to a 12? And is that the same thing I do from a 12 to get to a 21? So let's see if there's a common difference here. What is 12 minus 3? That would be 9. Is that the same as 21 minus 12? That is 9, yes. So, and then we add 9. It looks like 9 is consistent, so this is definitely arithmetic, because not every sequence is arithmetic. The A value is the number sitting in the first position. Remember, that is T1, which happens to have the value 3 sitting in there. So we have our A, we have our D, and when it said general term, we don't have an N. N is going to be left as N because we want to make sure that we can substitute in any N later for it. So Tn equals A plus N minus 1D. Sub in what you know. Tn stays Tn. Keep it general. Right? This is like f of x notation. Right? That's basically what this is. We're keeping it general. We're not replacing N yet. A is 3 plus, again, N we don't have, so we keep it. N minus 1, D we do have, which is 9. So unlike when you do know N, you actually just work it out. What we're going to do here is we're going to clean this up. And we're going to distribute that 9 to the bracket. So we're going to get 9n subtract 9. And then we're going to collect like terms. 9n, 3 minus 9, negative 6. So the general term is, the general formula for this sequence is 9 times the position number, subtract 6. There's your f of x formula that will help you find any value in any position for this particular sequence. So if you want to know the 900th value, then you sub in 900. And that will help you figure that out. So obviously much more efficient than having to figure out all previous numbers in the sequence. We're going to use this general term now to determine the 40th position. So who's sitting in the 40th spot? So T40 is what we're looking for. So T40 equals 9 times 40 minus 6. 9 times 40 is 360. Then we're going to minus 6 from that, and we're going to get 354. So 354 is sitting in that particular spot. All right, determine the general rule using recursive formula. All right, so the recursive formula for this guy, if we wanted to figure it out, would be the previous number, add 9. The previous value, add 9. So it looks like whoever is in the position before, we have to then add 9. And you always need to know where you're starting, given that the first number is 3, because you can't find T1, right? Because there is no T0. So you always have to be told who T1 is, so that T2 would be then the next one you would find, and then T3 after that. That would be the recursive formula. Now, we're not going to go and find T40, because then that means we have to find T2 all the way up to T39 before we do that, and I'm not going to do that. So let's now look at another sequence, 18, 11, 4, negative 3, just to show you that the common difference isn't always positive. Numbers aren't always going up, right? They could be going down. But we do the same thing. A equals 18. So your first value is 18. Common difference, if there is one, 11 minus 18, right? Second number minus the number in front of it is negative 7. 4 minus 11 is negative 7. Negative 3 minus 4 is negative 7. They're all negative 7. It's asking us for a particular value. So we know n is 30 in this particular case. Not asking us for the general formula, but a very particular number, position. So again, since it's arithmetic, Tn equals a plus n minus 1d. We can do the Tn formula first, or we can sub in 30 right away. I'm going to keep it general just to start. 18 plus n minus 1, and d is negative 7. Then I'm going to distribute the negative 7 to the bracket, keeping the 18 in front for now. N times negative 7 is negative 7n. Negative 1 times negative 7 is positive 7. So negative 7n, positive 25. This is called your general term. I can use this now to get T30. I can use it to get anything now. T30, so the n got replaced with a 30, which means this n gets replaced with a 30. Positive 25, so that's negative 210. Positive 25, which is negative 185. So again, it's as if you did this. F at 30 equals f at x equals negative 7x positive 25. We taught it to you before as function notation, right? That's all it was. A linear graph, like a line, y equals mx plus b, with f of x in front. And now we're replacing the x with a particular number. That's all we're doing. So we've just changed the notation style, but the actual meaning is the same. So you just found a particular point on the graph. When the position value is 30, the y value is negative 185. Alrighty. So if Leanne invests $500 into a GIC, that's just a guaranteed investment certificate, that pays her 4% simple interest. And when you hear simple interest, you just have to think linear growth. So she gets 4% extra every year on the 500. When will her investment be worth 600 bucks? So what happens is she put in $500. She walked away. She comes back a year later. Sitting in her account is 500 with an extra 4%. Now remember that you put a 1 in front, so 4% is 0.04. You know that. You put a 1 in front because it does the adding on for you, just like we do with tax. And then the next year would be 500 plus 1.04, and then another 1.04, right? So basically, what's happening in her sequence is 4% of 500 is 20 bucks. So she made an extra 20 bucks. The next year, she's going to make another extra 20 bucks. So now we're up to 540, and then we're up to 560, and then dot, 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 right? We know basically when she's going to reach 600. It's not that far down the path, but how do you use the formula in order to find that out? So we know she started with 500. We know the common difference based on this sequence is 20, right? This number minus this number, that number minus that number is 20 bucks. We know, though, that we want it to get to 600. So 600 is the value we're interested in, right? So the value we're interested in is 600. We don't know what position that's going to happen. Is it year 1, year 2, year 3, year 4? So we're trying to figure out the position for a particular value. So this is how you use the formula to find n. So you start off with it as normal. Sub in what you know. The value I'm interested in is 600. So it's like I'm giving you the y value, and you're going to give me back the x value that created that y value. Again, we did this when we did function notation. A is 500. N I don't know, but D is 20. Okay, so that's the way you write it out. Distribute like you normally would. We'll deal with the 500 later. Plus 20n minus 20. You can collect like terms. So we have 500 minus 20. What is that? 480 plus 20n. So then we're going to subtract 480 on this side, and then we're also going to divide by 20. Might as well do that all in one shot. So 120. Yeah, 120 divided by 20, you get a nice value like 6. So that means it would take 6 years to reach 600 bucks. That's what that tells us. The 6th position, and each position is a year. So 6 years. So that's how you use the general term when you know a particular value and you want to know when does it occur, right? You can rearrange by putting the value in the value spot, which is Tn, and rearranging for n. So that means 6, 600 is a point on that graph. That's really what we found. Now, the last situation that you can see is, what do you do when you're given two non-sequential terms? Non-sequential means terms that aren't back-to-back, right? They're not related to each other. So here, T7 is 53. So in the 7th spot is the number 53. And in the 11th spot is the number 97. So they're not back-to-back terms. There's a couple of spots in between them. And you're told that it's arithmetic, otherwise you wouldn't know. We have to figure out what's going on with the sequence. Can we come up with a general formula? Can we write what the terms look like? And then use that in order to figure out a very particular term. So what we need to do is we're going to figure out mini equations. So T7 equals 53. And we're going to use the other piece of information to figure out, so T11 is 97. So I'm separating them. I'm going to deal with them individually. This tells me that n is 7 and that the value sitting in the 7th spot is 53. So when I do my general formula, Tn plus n minus 1d, the value is 53. I don't know a. I don't know the first number in the sequence. I do know n. That was 7. But I don't know the common difference, so that's d. I'm going to clean this up. 53 equals a plus 6 d's. Okay, so that's the best I can do as far as this guy goes. I'm going to repeat on this side. So again, the 11 is the n. The value sitting in the 11th spot is 97. Tn equals a plus n minus 1d. 97 equals a plus 11 minus 1d. Most people will just go 97 equals a plus 10d's. So what you see here are two equations with an a and a d unknown and an a and a d unknown. When you have two equations with two unknowns, you did this back in grade 10, where we taught you 3 ways to figure out how to isolate and solve for these two missing pieces. And one method was graphing and looking for the point of intersection. Where does this line intersect with this line? We could do that, but I'm not going to. The second way you learned was substitution, where you rearrange and get one of the letters by itself, and then take that chunk and substitute it into the other formula and do some algebra, rearrange it, and substitute it back. You could do that. That would work. But you notice how the a and the d on the same side and the a and the d on the same side? I would do elimination here, just because it seems to be set up nicely for elimination. So how elimination works is you stick one equation on top of another equation. So 53 equals a plus 6d. It doesn't matter who goes first. 97 equals a plus 10d. And you notice that you already have 1a and 1a. That means if I subtract these two, the a's will go away, which is what I want. So 53 minus 97 is negative 44, 0 a's, and 6 minus 10 is negative 4d. Do you notice now how easy it is to isolate for d? Divide by negative 4, divide by negative 4. There you go. D is 11. So we figured out what the common difference is. Now we can use this common difference to now figure out, okay, what is a? So to get a, we can just use equation 1 or equation 2. Doesn't matter, they're both the same thing. 53 equals a plus 6d, but d we know is 11. So 53 equals a plus 6 times 11. 53 equals a plus 66. 53 minus 66 equals a by himself. That's negative 13. So the first number in the sequence was negative 13. So do we now have enough information to figure out the first sequence? Yeah, it went negative 13. Then we added 11, so that'd be negative 2. Then you add 11, that would be 9. Dot, dot, dot. That's what the sequence looked like. To get the general term, Tn equals a plus n minus 1d. Tn equals negative 13 plus general n, and the d was 11. Negative 13 plus 11n minus 11, which is 11n minus 24. And you can go negative 24 plus 11. It really doesn't matter if you put the 24 first or you put the 11n first. So here's our general term, and we're going to use that in order to find what it's asking us for here. So T100, who would be in the 100th spot? 11 times 100 minus 24. So what is that? 1100 minus 24, which is 1076. So the number 1076 is sitting in the 100th spot. We wouldn't have known that unless we got the general term, and we couldn't get the general term until we figured out A and D. And we couldn't figure out A and D until we did a point of intersection algebraically, either using substitution or elimination. I picked elimination just because of the way it was already set up, with the A's already matching and easily subtracted from each other to be eliminated. So this is what you do when you have an arithmetic situation with two terms that aren't back to back. If they were back to back, i.e. if they were sequential, you would just subtract them and get your D. But they're not back to back. And we're not going to do trial and error where we try to figure out how many numbers must be in between 53 and 97 for these four spots, because the numbers could be very much separate from each other, right? So you don't want to have to do it that way. So again, your homework, If you like this kind of stuff, then data management is probably the grade 12 course for you, because that's where this topic continues. So page 424, again, 1, 3, 5, 6, and 8, skip the recursive, and 9 through 50 on page 424. All right, let me know if you have any questions.